Example number 6, or 7, I'm sorry. Let's take the limit of a constant. Let's do the limit of 3. As x approaches 3 of this particular function. Now this is like a step function. It's an integer function, and what it does is the y values are just integers. So it doesn't matter what you plug in for the x value. What matters is, well, let me show you how to graph it, and then you'll get a better idea of it. So to graph this in your graphing calculator, what you're going to need to do is go into your y equals, and you'll have to hit catalog. So you go second catalog, and if you look for the little I, which is somewhere in here, I can't see it. Is that it? Yeah. There it is. And so this is what we call a step function. And whatever value I plug in for x, it'll automatically evaluate it at the closest or the next y value. So let's look. I'll be quiet. I can't talk today. I'm tired. Now on your calculator it looks funny, but let's look at it from the table of values.
How come mine doesn't look like that?
Yours will probably look like steps. They won't be connected.
Oh, mine looks like a straight line.
You didn't enter it incorrectly.
You put in 3. You didn't put an x.
So let me show you something here. I'm going to put in like a 0.25. And I'm going to start at 1 so you guys could see this. Or let's start at 0 so you guys could see this. Now the table of values, here's what it looks like when you look at the table of values. In other words, when x equals 0, so it doesn't necessarily, it doesn't like round, I guess you would say it rounds down unless you're at the integer. Okay, that's the best informal, regular, everyday language explanation. So when x equals 0, y equals 0. When x equals negative 2,5, y still equals 0. When x equals negative 5, y still equals 0. And it doesn't equal 1 until x equals 1. So it's really the integer, or the number in front of the decimal. That's what this function automatically rounds it to that number. And there are some practical applications for this. But basically this is what it looks like. So the question is what is it when it is 3?
3.
Well, hold on, we got to think about this. It's defined at 3. But I'm gonna introduce some new notation to you guys too. This is what we call a two-sided limit. We can also take a one-sided limit, where we could take the limit from negative infinity in the x direction, or this usually means from the left-hand side.
Is your first thing supposed to have a little plus sign by it?
And we could take it from the right-hand side.
Oh, okay.
All right. So now what this looks like graphically is that if I were to draw a graph, with my notation, in order for me to have a two-sided limit, it has to approach the same value from the left and the right. So technically what I want to do, when we have this positive and negative sign, what we're referring to is the x-axis. If we go to the right on the x-axis, we're going towards positive infinity. If we go to the left on the x-axis, we're approaching negative infinity. So when I say take the limit of this function as x approaches 3 from the negative side, what I want to do is I'm going to come in here. When we want to look at 3 from the left-hand side, we're going to approach 3 from this side. Now it doesn't matter what the value is. What matters is what is it approaching. So if I look at that pink arrow, what value does that look like that is approaching from the left-hand side? 2.
Wait. From the left?
We're looking at the y value. So this open, it's not defined, but isn't this really 3, 2? Where that open circle is? And so when we're looking for the limit, we're looking for the y value.
Oh.
So that is 2. Now the right-sided limit is when we're coming from the right-hand side. So if we're coming from this side, this approaches the point 3, 3, right? So this one will be 3. Since the left-handed limit or the right-handed limit do not equal, what does that tell you about the two-sided limit? Doesn't exist.
Wait, what? Since they don't equal. Oh.
They have to equal.
Okay.
To be. I see.
So sometimes in calculus, we're only interested in the left-hand side or the right-hand side, or as we approach from negative infinity or approach from positive infinity. So we've kind of skipped over this, but what you should know is that the limit of a function, f of x, only exists, it only exists if the limit of that same function exist on the left-hand side and exist on the right-hand side. Okay?
So the right and the left have to be equal?
Yeah.
They all have to equal for them to equal. Now if these two don't equal, then this can't equal. Does that make sense?